Hi, I'm Sharav.
And I'm Zach, and we just want to introduce you to this project we did. The main goal of our project was just to explore a little bit about how unsupervised artificial intelligence programs worked. This was really an expeditionary project, and we have a lot of other ideas of how to apply it. And this was just a great way to lay a foundation in artificial intelligence for the both of us. So the general idea of the project was to look at the way that the different alphabets of different languages have different similarities and differences. So we used an artificial intelligence, an unsupervised artificial intelligence program to group these alphabets. We used a variety of different alphabets from different parts of the world. So we have the Arabic alphabets, we have some of the Indian alphabets like Hindi, we have a bunch of different alphabets. And just one thing to note, for example, Ukrainian has less because it shares some letters with the Cyrillic alphabets. So we have most of the letters in the Russian alphabet as opposed to the Ukrainian alphabet. So here's the big Cyrillic alphabet, while this just has the extra letters. That's all. So, Sharab, do you want to explain how a unsupervised artificial intelligence learning program works and what it does in general?
So the type of algorithm we use was called a k-means, and while I can't really get into the math of it right now, essentially all it does is it takes some data and then sees like which data fits best with it the most. If you have like a graph, for example, and you have a bunch of different data points on your graph, you're creating a scatter plot or something like that. On the scatter plot, what the k-means would do is it would basically circle all the points that are like closest together, which is why it's called sort of a cluster when it does that, because it's essentially just grouping all the points that are the closest to each other and assuming that it's a category. So unlike supervised machine learning where you give it a label and it asks you to figure it out based off of the labels you've given it, unsupervised is just giving it some data and figuring out what classes it has or how the data might be categorized in any way.
Yeah, so in order to reduce the possibilities that there would be other factors affecting the efficiency of the code, we used the files intrinsic to a computer and the font files within it to generate images all in the same font size using the same font family where possible. There are a couple examples where we couldn't, but this allowed us to standardize them to some degree. And this is the code. We just got it off the computer's font path. Here's the code for the clustering. Sharab did this part, so I'll let him explain.
Yeah, so we used a model called VGG16, which is a really robust image classification model from Keras, so you can actually get that if you install Keras from Python. Once you get VGG16, all you have to do is pre-process your images. So we just resized all the images in our data set to 224 by 224 pixels, added it to an array. Once we did that, we initialized our VGG16 model, created a PCA that basically reduces dimensionality or just makes the images easier to interpret for the algorithm. Then we create this k-means sort of object in which we have the number of clusters. So in this case we had 100. We'll show you the clusters in a bit, but we created the clusters and then assigned labels for all of them. Once we did that, all we really had to do was fit features reduced, which is just all our images, and then for each image we assigned it a label based off of these labels, and then using those labels we were able to sort of sort them into different file paths on the computer, so that way we actually have different folders of all the different images that fall into one cluster or another cluster and stuff like that.
Okay, so now we're going to go ahead and show you the clusters. We ran it 4 different times. The first 2 times we ran it with 5 clusters, and then the third and fourth we ran it with 30 and 100 clusters respectively. So we're just going to show you the first time with 5 clusters. I'll explain how I interpret the thought process behind some of them. In this cluster we see lots of bends and curves, but not quite like full circle types. So like this letter has a bit of like a 90-degree curve to it, where it would be like a quarter of a full circle. So not quite a semicircle or a circle, but sort of like just a quarter of it. So we see that with a bunch of the different letters. Some of them you could argue are more of 180 degrees, but for the most part, there are lots of these 90-degree curves, and that's what I think is the distinguishing factor of this cluster. The next cluster is more of these 180-degree curves. So we 180 there, sort of semicircles. Some of them are also more like O shapes, but for the most part, we see this U-like shape. Even here, it's like cut into half. And I'll just scroll through if you want to look through them. But overall, this is one of the distinguishing factors. Another thing is these little circles from a couple of the languages that are all put into this cluster, which I think is interesting. So because it has such a small amount of clusters, it has to group things that might not be completely similar, but have small similarities. Okay. Cluster number 3 is more of these full circles. So we see like letters that look like C and O, and lots of more bendy letters. So for example, this looks more like a theta, and I'm sure we'll see the theta down here. Yeah, here it is. And if you scroll through, it continues to follow this theme, lots of circles and shapes like that. Cluster number 4, both the cluster number 4 and 5 have lots of straight lines, but there are some subtle differences that I was able to find. The major one being that with cluster 4, there's lots of diagonal lines as opposed to straight horizontal or vertical lines. So everything seems to have a little bit of a curve or a diagonal to it. Nothing is like completely straight. Whereas with cluster number 5, there's lots of these straight lines. So for example, this one has letters that look like the H, while cluster 4 has letters that look more like K with these diagonal lines attached. So I'm just going to scroll through that really quick. Korean is mostly in this category because Korean is one of the more linear languages. And yeah, it's just interesting to see the way they're grouped here. Now let's move over to the 100 cluster run. I'm not going to show you through all of these. I'll just open up a couple. But you could see here we have W, V, and Y, and I'll just open up a couple. Do you have anything you want to say while I'm showing the viewer some of these clusters?
Oh yeah, I mean, this is a fun project to do. In the future, we do want to look into some more ways to sort the letters. So we were talking about, pronunciations, how those factor into the way the letter is shaped. So if we could pair the pronunciations with these, and then see how each of the clusters are, pronounced generally, that would be interesting. Another thing that we talked about was actually running it as if, we're basing it off the pronunciations instead of the actual shapes of the letters. So then we would see, do all the ahs go with each other, do all the oos go with each other, stuff like that. And then, just to improve this project, I know we had some, languages where the font would be different, and it's hard to get scripts for some of these languages that don't look different. But in the future, if we could get access to more standard universal font, because Arial Uni didn't work for all of them, that would be good. We could see how that affects the results. And yeah, I mean, this is pretty nice overall as a way to learn unsupervised machine learning. So anything else?
I think that's all. Hope you enjoyed, and we're going to sign off here. If you have any questions or want to see more of the data on your own, just let us know and we could send over the code or any of the files. Bye.
See ya.